A warm welcome and very good evening to one and all present for the day 3 of the 5 days national level virtual workshop on hands-on SPSS, organized by PG Department of Commerce in association with IQAC and Research Cell of the college. I, Navyashri, PG coordinator of the college, will be the host for today's session. First and foremost, I would like to welcome our esteemed resource person, Dr. S. Gokulakrishnan sir, who will be emphasizing on the use of SPSS. I wholeheartedly welcome you, sir.
Thank you, ma'am.
I also welcome all the participants who are eagerly waiting to learn more about SPSS and get the insights of it. So without wasting much of our time, I will hand over the session to our resource person, Dr. S. Gokulakrishnan sir. So please take over.
Thank you, ma'am. Good evening, all of you. Let us quickly recall the yesterday's experiments, especially when it comes to the transformation of the data. And then we had the validation, data validation, how we need to set the procedures, the rules. Then we had discussed about the reliability with the various methods. So if any queries or any doubts is there in that, we can spend for 1 or 2 minutes. If not, we can proceed further about today's topics. That is how to test the normality of the data. First thing which we are going to focus it today. I think it will take nearly 30 to 40 minutes of time, which is very essential. We know very well that how the normality distribution is going to be useful when we are going to preparing our data for any sort of analysis. The second part of this today's session, we are going to have much more important analysis, whereas it is completely known as dimensional reduction scaling technique, which is factor analysis. And today we are going to concentrate on the exploratory factor analysis, how we can execute the exploratory factor analysis in the SPSS, and what are the things we need to do it, and what are the major elements we need to do it. Then further, if time permits, we will start with the descriptive statistics today. Okay. So this is the plan, and I believe all of you have opened your SPSS data editor window, and as well as the Excel file which I have shared you. Fundamentally, we need to recall and we need to decide what we are going to do with. Accordingly, only it is going to be happen. Okay. So if any doubts is there, based on the previous 2 days structure and the listening, you can raise your hands and then ask questions. If anything is there, we can address it for another 3 to 4 minutes. Not, will proceed with the testing of the normality of the data. Quickly.
So
I think I'm audible to all. Yes.
Vaishnavi Kulkarni ma'am has raised a hand. Ma'am, if you have any queries, you can ask. You can unmute yourself and ask.
No, I think Vaishnavi ma'am's hand is raised from the beginning when I joined.
Well, I don't think there is any question. You can proceed, sir.
Okay, fine. One important thing for all those who are listening actively, as well as those who are practicing actually, okay, so that the hands-on training you need to do it simultaneously, else it is going to be very difficult for you to cope up and grasp and understand the elements, and that is going to be very, very essential one. So let me share my screen, both the things, and accordingly we'll proceed further. Just hold a second, it is getting shared my screen. Navya ma'am, is my screen is visible, that data editor of SPSS window?
Yes, sir, it is.
Okay, then once again, I would like to check with Excel. Excel also is visible if I'm correct.
Yes, sir.
Okay. Quickly, we will remind it. Yesterday, we had completed at last with the reliability test. I have told you that the variables would be measured under by the many statements. Okay. And it could be 4 or it could be 7 or it could be 8. And accordingly, only we need to consider reliability. It is not as a whole. Second point, again, we need to remember here it is the criteria. Okay, know how much Cron branch alpha value which we are getting. It is always advisable that we need to have it more than 0.5. And when the range gets increased, then the reliability it is going to be higher. And later on, we had the complete discussion, especially when it comes to the how we need to remove and how we need to handle the variables, sorry, the statements. Okay. So today, the agenda, as I told you, we are going to have two important aspects, which is very essential when we are going for the testing of the normality, as well as we are going for it. Okay. Let us start with the testing of normality. How do I check the normality of the data, whether it is going to be useful or not, and how do I understand whether my data is normally distributed or not? Okay. The first step, it is just go to the analyze menu bar. Please make a note of it, all of you. Go to the analyze menu bar. And then go to the analyze menu bar. Click on descriptive statistics. Click on descriptive statistics. And then go to explore option. Again, I'm repeating. Test of normality in SPSS data editor, it goes like this. First one goes to the analyze and descriptive statistics. Click on explore. Then you will get a dialog box like this. Okay. I believe everyone is opened. Okay. I believe everyone is open. Ma'am, is that recorded started? Okay, fine, it is started. Now, as soon as you have opened the explore dialog box, you could able to find it in one column and one box, all the variables which we are included in the data set, it is available. The second side, you can see that the dependent list is there, factor list is there, label by cases, sorry, label cases by the display. Okay, this is what you want actually. Do you want to have only statistics or plots or both? Okay, normally it is insisted that we need to go with the both so that we will get all the related things. Okay, initially what I'm going to do with it is I'm going to have one or two variables. Okay, let us take only one variable initially. So when I click on the variable into the dependent list, okay, again I'm repeating, I'm taking the same variable which we have used yesterday, that is authority. I clicked it and immediately the OK button and paste button has been enabled. Okay. The other two boxes, you may ask me whether it is going to be useful or not. Okay, whether it is going to be useful or not. Yes, when certain conditions is required, when I have some kind of categorical things, need to based on that I want to check the normality, means we can go for it. Label by case is also the same case. But in the primary understanding, I would suggest you that go to the dependent list only and then go for it. Once again, I'm repeating, go to analyze, descriptive statistics, click on explore, and then you will get this dialog box. After that, out of the available variables, I have chosen only one. Now, another thing it is, I have explained what is about the display. That is both what kind of output you need, that's it. It is whether you need the output in terms of matrix alone or plot alone, otherwise both. Then click on the statistics button. Here you have to say what you want actually. By default, once again I'm repeating, go to the statistics option, click on that, and immediately explore statistics dialog box appears. Explore dialog box appears. Let me tell you, by default you can able to have it as descriptives has been enabled and confidence interval for mean it is 95%. And estimators is there, it is a mean estimators. The outliers, yesterday we have been speaking about it, no, the variable score and respondent score and those things, it is going to be there. And percentiles. Okay, what we are going to do with it is one by one we will try it out. Normally we won't go with the M estimators. So we will try to understand what are the outliers are available in this particular variable or maybe the entire data set. Okay, again I'm repeating, after entered in the explore statistics dialog box, agenda here it is to check about the outliers, because that is the thing which will create some problem when we are going to proceed further in terms of inferential statistics. It is always better we have to go with the outlier initially. Combinedly also we can do it, that provision is there, but I will do it one by one so that you will be able to understand. Just enabling the outliers option, click continue. Then go to plots. Here you can choose whatever the plot you want to have it. The stem and leaf, if you want to have, you can. Histogram also, but it is not required in general. You go to the normality plot with the tests, because this is the plot which will help us to understand completely about the distribution of the data across that variable or the statement. Okay, across the variable or the statement. Once again, I'm repeating, you just leave it the factor levels together. Then as it is by default, the stem and leaf method, it is there. It is a one method of showing your graphical representation. Next thing it is, I need to enable normality plots with the test. Normality plots with the test. Once I have done that, click continue, and then go to the options. Here you can, it is all about missing values actually. Okay, exclude cases listwise or exclude cases pairwise or report values. By default, let it be there with the case wise. Okay, listwise only. Just click continue. And everything I have done, and I have chosen only one variable for our understanding. Later we will go with the 3 or 4 variables together. Okay, so as of now, I think you do not have any queries. Assuming that you do not have queries, I am proceeding further. Let me repeat it. The steps, I have went to the analyze, then clicked on the descriptive statistics and selected the explore option. I got this dialog box and I have chosen the dependent list, any one variable as of now. Then I have chosen the statistics option. In that I have enabled only outliers. By default, the descriptives it is going to be there. And under the plot, I've chosen only normality plots with the test. Rest it is going to be by default it is enabled. Then options, exclude case wise list, and then display, as I told you, we need both so that you can able to understand the matrix wise as well as the plot wise. Okay. And I'm clicking OK. And immediately the results is going to appear. Okay. Just type me in chat box how many of them have got these results. The authority, it is a name. Then you can see that title is there. Then stem and leaf. Then the normal QQ plot, it is going to be there. Then detrended normal QQ plot and box plot, it is going to be there. Okay. Along with that, you will get test of normality values, descriptive as usual, that statistics. What are the extreme values are there, and everything is going to be there. So kindly just text it in the chat box. Otherwise, you can unmute yourself if you are facing any problem in terms of getting this output. I mean, anyone has typed it? Anyone is facing a problem in terms of getting the output?
No response, sir. Hopefully, participants have tried it and they've got the right answer.
Okay. Now, if any queries is there, please let me know about it. Okay. Now, the question here it is, after starting this, okay, after getting an output, how do I understand whether my data, whichever I have collected, is normally distributed or not? First question. Please make a note of it. First thing which I want to answer it, the question which I want to answer it here it is, whether my data is normally distributed or not. First one. The second one, I would like to understand, okay, about the outliers, okay, which is believed that things will disturb our analysis. That is known as extreme values. You can see that. And the third one, how much? Okay, what are the two different authors' methodologies are available when it comes to the tests of normality? And finally, we will be checking with the normal QQ plot how the data is loaded across that linear line. Okay, normally we will measure it by using this linear line only. When it is goes much of outlier, how it is going to be. And finally, this one, box plot. Okay, I will tell you what would be there, what would not be there when it comes to the box plot. If outliers are available in the data set, how it is going to be appear. And if it is a perfect data, how it is going to be appear. So these are the things we need to keep in mind. Okay. Let me start explaining the first table which we need to look into it when I'm going to start describing or interpreting the normality test of normality. Please make a note of it. That is the first table I need to look into it. Okay. The descriptives is okay because it tells about complete aspects of the particular statement or a variable. But this one, test of normality, will have this particular thing. Okay. Please make a note of it. In the test of normality table, you can find it. There is a two methods has been given. Olmegro-Simrov method and Shaprio-Wilk method. These are the authors actually. Okay, is an authors. Condition it is this. Please make a note of it. If the sample size is less than 2000, if the sample size is less than 2000, I need to follow only Shaprio-Wilk model of test of normality. If less than 2000, if it goes more than 2000 sample size, I can go with KS and go with the KS. Once again, I'm repeating. Okay, the first one, in case if my data set have less than 2000 as a responses, then I have to decide about this. My decision is completely based on this. And if it is more than that, I will go with Kolmogorov-Simrov test of normality. I hope it is clear. Now, how do I say, okay, by looking at this particular table, how do I say that whether my data is normally distributed or not? Condition here it is the thumb rule. Please make a note of it. Some thumb rule says either it is going to be Kolmogorov-Simrov test of normality, nor Shaprio method. Okay, it must be okay 0.05. Okay, please make a note of it. 0.05. If it is more than that, okay, if it is more than that, the data is normally distributed. The data is normally distributed. Okay. If it is there, it is going to be normally distributed. And when it is says in our thing it is 0.00, it is there, and static value also it is 0.852, which means it is normally distributed, and then we can proceed further on that. I hope you understood. Again, I'm repeating, the thumb rule says 0.05 and above. It is not about significant p-value. Please make a note of it. It is about the 0.05 has to be. Okay. Now, in case if you have a doubt, okay, how do I understand that? Yesterday I have told you, when we are going to interpret it, go to help menu, click on statistical coach, click on statistical coach. I will show you how you can interpret on your own. It's getting loaded. Just hold a second. Because sometimes we may forget the thumb rules. It doesn't mean that every time we need to remember everything in our mind. But the statistical coach will help us. Okay, if the window gets opened, then you can type test of normality. Okay, test of normality. Immediately, it will tell you on which condition and how it is going to be happen. Okay, in which condition and how it is going to happen. For example, here I'm going to type it. Test of normality. Just click on it. You will get a complete list which is telling about how the execution has to happen and how do I decide whether the normal data was normally distributed or not. It's getting loaded. Just wait. Meanwhile, we'll go to the next option. Okay, this is the first table, as I told you. This is the first table I have told you. Yes, you can see that I have this. Now I wanted to understand this particular example. You click that, and we'll go with this is distribution normal. Okay, so then you will be able to get it. The same thing it has been given here. Are the distributions are normal? You can read it. The test of normality overlay on the normal curve on actual data to access the fit. Assess the fit. A significant test means it fits is poor. For the standard alloy, the test is not significant. They fit normal curve. However, the premium alloy, the test is significant. They fit normal curve poorly. And it comes to our output, it is poor because we are not taking too many variables. Hence, the distribution of the variables, date responses also it differs. So my conclusion here it is, since the significant value is less than 0.05, I'm telling that there is a poor fitness towards normality, the curve. Now, the next thing, the next table which we need to go into the interpretation, it is go to extreme values. Please make a note of it. Go to the extreme values. Okay, the table called extreme values. In the extreme values, you can find it. It has been divided into two major categories, that is highest and lowest. Highest and lowest. And it comes to the highest, the top 5 recordings only it has been shown. Even if you have 1,000 data, 2,000 data, or even 1 lakh data also, only that is going to be shown. Only partial list of cases with the value of 7 shown in the table, upper extremes and lower extremes also it is going to be given. This number, can you able to find it out? The case number 74, which means respondent number 74 response towards this question is abnormal or extreme value. Again, I'm repeating, the respondent number 74, that is nothing but case number. In the value, it is 8, it is an extreme one. Similarly, 75, 63, 64, and 67. Okay. And when it comes to the lower part of it, you can take it 7, 8, 9, 10, and 11. So it's saying that it is an extreme level. Okay. So by removing, you may ask me, sir, how we can proceed further. First, try to understand the test of normality table. I have told you, as I told you, it's a poor fitness. The second one, it is, I told you that extreme values consideration. The third table, which we need to look into it for further interpretation, it is go to normal QQ plot. Normal QQ plot. One thing you need to understand, normally the normal distribution plot goes in a linear manner. It goes in a linear manner. And it will tell you how the expected normal curve it is going to be there. So almost goes very close to the linear curve. Okay, almost it is closer. Now, in this, we can able to understand how the data distribution it is. That's it. We can't do anything further into this. At last, I'm telling you the box plot. There's a box plot. In the box plot, you will have like this. In case, in this data set, we do not have any outliers. We do not have any outliers. If there is an outlier, out of this box, please remember, out of this box, some small circles will come by mentioning the case number. By mentioning the case number. And one important clarification I would like to give it here. Okay, extreme values or extreme cases are not outliers. Please make a note of it. Extreme values or extreme cases are not outliers. Outliers is something else which is abnormal. So this is the complete scenario of how do I execute and how do I understand the test of normality using SPSS. Okay. So what I will do with it is instead of just now we had only one variable, that to one method actually. Okay, that to only one method we have done it. Now what I'm going to do with it is I'm going to go for percentiles, okay, which is another method. Let us understand how it is going to happen. Here you can see that percentiles also it has been given, and in the same case it is going to happen. A normal probability and box plot it is going to be there. Both are it is going to be useful. There is no much thing it is there, and how it is going to be abnormal elements it is going to be there. Okay. Even if you want to use it both together, yes, of course, you can make use of it and finally you can conclude it. But as for the data which is given to you, which I am using it, is a poor fitness when it comes to the normal curve. Okay. Let us use minimum of 4 variables together, sorry, 4 statements together, which is contributing to a single variable. I'm going to choose everything. Okay, I have chosen. Now statistics, let me have outliers 2. Okay, the plot, as I have mentioned, normal plot with the test. Options I'm going to enable and click OK immediately. The analysis is going to done. It is again, it's a kind of repetition probably. Every statement wise it is going to be. You can see that this is going to be there. Let us understand what is the test of normality. This happens. Okay, everything together it is available. Now almost it is going to be in that particular thing. So the distribution of the data normally fits not fit with the curve. So this is the conclusion which we can take it. And when it comes to the outliers, as I told you, in the authority there is no outliers are available. Here also own scheduling also there is no outlier. Okay. And it is going to be the next one, freedom to decide also there is no outlier. And finally, the inference also there is no outlier. You can see that very close association is there with the linear one when it comes to the inference of work demands with the family life. Okay. And one important thing we need to remember here it is First thing it is, as we discussed, the normal distribution, data normal distributed or not, we are checking. Another one it is, we are much worried about the outliers. If outliers are there, then we need to remove it. If not, you can leave it as such, and then you can proceed further on this. This is the method of testing the normality using SPSS. Testing the normality using SPSS. Let's say that if I want to have factor wise also, yes, you can. Again, it depends on your objective. It doesn't mean that you need to do that. So here, based on that, how it is going to happen, and you can see that when it comes to the variable which we have taken, how it is going to be happened, and everything is going to be there. So this is the complete overview of test of normality using SPSS, and interpreting also we have done it. In case, again I'm repeating, if in case any outliers are there, it would be there in this box plot only. This box plot only. The box plot will have some zero, something like that here, and you can able to easily understand whether the outliers are there. Out of this one only, here would be there, here would be there, here would be there. That small circle will carry the numbers. The numbers indicates the case. This means here all about responses that is going to be happening. So this is all about testing of the normality. Testing of normality. Any queries? I believe everyone got the results, and I believe that everyone is doing this test along with me. Okay. If you have any queries or any doubts, please let me know quickly. Any doubts in the chat box? Once we have done this, then we need to proceed further for the next thing. Okay. There are 4 things I have told you. First, we need to take test of normality, then extreme values, then go for normal QQ plot and box plot. By using all these 4 elements, we will describe and understand how it is going to happen. Okay. Yes, any queries on this? If everything is clear, then we can proceed with the factor analysis. Yes. Any queries or any doubts? The help menu, it is going to be very useful. Okay, please make a use of elements, and then accordingly we can go for it. Okay. Any queries from any participant? Quickly tell me and update me. Accordingly, we can understand.
There are no queries in the chat box, sir. One of the participants is telling it is clear, sir.
And I would insist all of you, please make a note of these points, because when we are listening, it seems to be easy, but when you are going to apply it, and when you are going to do it on your own, you will find difficulty in this. It is better to make a note of the points whichever I am telling. The order also, it is very important. Straight away we can't jump into the extreme values nor with the box plot and all. There is a sequence. When you follow that sequence, then everything goes well. Okay. What I'm going to do it is I will save this output in my folder. Okay, so that going to be useful. Okay, so test of normality. See, now I think the second thing which we are going to do it is factor analysis. Okay, factor analysis. Someone tell me quickly, if possible, what do you mean by factor analysis? Already everyone must have learned from our PG programs, the research methodology. Just I wanted to hear from you, then from that we will take it further. And what is factor analysis, why it is required, and how we can execute it in the SPSS, and so on. Quickly. Okay, fine. I think interactive levels are less. What I'm going to do what it is, I will be moving further on this. So let us call any one or two participants, whether they understood or not. Accordingly, we can proceed. I will do what it is. Ananda Kumar sir, if you are, just unmute your mic and tell me. Ananda Kumar sir or Archana, maybe Jennifer, whomever. Because we need to have complete understanding of test of normality, then only we can able to proceed further when it comes for the factor analysis. Navya ma'am, you got the clarity?
Yes, sir, it is clear.
Okay.
Dear participants, kindly respond so that we can have a track that you are following. Sir is mentioning some names. Those participants can please respond, at least tell yes or no. That would be very much beneficial.
No, because everyone knew about it, no? It is, what is that,
So
sir?
there's a
Yes.
question in the chat box.
Hmm.
Sir, it is to identify the correlated variables in the data.
No, it is not that. It is about testing the distribution of the data. Okay, Shruti Rekha, if I'm correct, it is testing the distribution of the data, whether it is normally distributed or not. When the data is distributed normally, the things it is going to be in our, as per our expectation, and it is false in the line. And the more number of outliers are there, then it is going to be very difficult to handle and so on. That is why it is going to be this particular thing we need to understand. Is it clear? Okay. I think it is clear, probably. Let me move on to the factor analysis. Okay, so let us understand what is factor analysis. From that, we will proceed further. You know, in every article, okay, even in every thesis, people are speaking about the factor analysis, which is very essential. And I'm going to finalize the questionnaire, especially using the pilot study data. Okay. And why it is carries much important it is, as we discussed yesterday, when I'm going to validate the variables, when I'm going to check the reliability, I can able to understand there are few statements may or may not be relevant to the study. Exclusively, we will remove that the variables are the statements which is not going to be helpful when it comes to the model building and so on. Okay. So in that case, the next element after doing that, we are going for factor analysis, where I will definitely tell that whether that variables or the statements is correctly comes under that particular factor. Okay. And ultimately, by end of the exploratory factor analysis, we can able to go with further inferential statistics. Unless or until, if you are not having a clarity with the exploratory factor analysis, the basic analysis when it comes to the inferential statistics, it is not going to be easy. At the same time, we may not be able to control the variables as well as the responses. That is why this factor analysis carries a lot of weightage. Okay. And simply speaking, it is a tool which is being used to reduce the dimensions. Let us assume that I felt that one of the variable, which is, let me go back to the Excel and then I will tell you, job autonomy. Initially, I felt that there would be 6 or 7 questions. It is going to be useful to measure that. But when I went to the pilot testing, I come to know that only these 4 variables it is being used based on the factor loadings. It's very important because we need to keep it precise. At the same time, the important statements we are not supposed to lose it from our study. And at the same time, we need to keep that literature survey also should be supported. Okay. Is it clear to all of you? Okay. Whatever it comes to my mind or whatever I have read it in the literatures, I will make a statements. Let us say that this author towards job autonomy has told 3 variables, 3 statements. The another author has told 4 variables in the statement. Okay. When another one, but when you are going to combine it, it may goes up to 10, 12 or 14. But when we are going to accommodate everything together, it is going to be much, much bigger, and it is going to be a burden for you as well as for your respondents. That's why we normally recommend the pilot study, and pilot study thinks it is going to be useful when it is not going to be there. Okay, so I hope it is clear. Shall I proceed further on this? Okay, go to analyze. I'm going to tell you how it is going to happen. Go to analyze, then dimension reduction. Go to analyze and dimension reduction. Click on factor analysis. Factor. Here itself, that symbol, that icon it is given itself, it will tell you. This goes in an something like 1 to many. Okay, that is the upper one. It is a variable, and the small red and green and all, it is going to be statements. So I'm going to confine that how many statements has to be there when it comes to this particular factor based on the factor loading. Now let us understand how do I do that. First of all, I'm assuming that this data which I have sent you, it is completely prepared data. We do not have what we can say that any irrelevant statements based on the pilot testing. Okay. However, let us understand how it is works and what are the things we need to look into it, and accordingly we will go for it. And I'm repeating, based on your literature survey only, we are going to do what? Okay. I'm assuming that let us take the second variable here, okay, because it has 8, if I'm correct, up to force to serve. Okay, this is what the variable statements we have. The variable, it is nothing but it is work family conflict. Okay, work family conflict. Those are the variables, and the factor analysis can be executed based on the selection variable also, but we won't recommend it unless it is mandatory or unless it is required. Normally in the social sciences, it is not required when we are going to decide about the factor analysis. Okay. As soon as I have chosen the variables, especially, please try to remember the statements related to the variable I have chosen. Okay. And go to the descriptives. Okay. I'm repeating once again, go to analyze menu bar, then click on dimension reduction. Click on dimension reduction and factor. Just click on factor. Just click on factor, and your dialog box appears. And I have chosen a set of statements which is representing one variable, So this is one method. Second method also I will teach you. Okay, I will tell you the second method also I will tell you. This is one method. And I have taken all the statements which is representing the particular factor or a variable. Okay. After that, I'm going to decide what I want to have. This is a crucial and very important function in the factor analysis. There are 2 important elements you need to choose it. One it is, under the statistics, you can find it initial solution is there. Under statistics, initial solution is there. Okay. In correlation matrix, there is an option called correlation matrix. Here, we are going to choose significant levels and KMO and Barclay's test of sparsity. Okay. KMO, it is Kaiser Meyer Tolkien, who is an author, the combined author who spoke about the sampling adequacy of the data. Whether the data set which you have, it is going to be adequate for further analysis or not. These two things are very important. Okay, without that, don't do anything. In case if you want to have, you can go with the determinant. Okay. So I would recommend all these three only. Once again, I'm repeating the factor analysis. Click on the descriptives. As soon as you click on the descriptives, you will get this dialog box. There is statistics, initial solution, and then correlation matrix. There is significance level and determinant and KMO, Bartlett test of specificity. You're done, just click continue. There are a lot of steps is there. Okay, because step by step you need to do it. Step number 2. Okay, step number 2 or 3. I'm sorry, it is going to be 3 because this is 1, this is 2, and this is 3. Extraction. Hopefully, you must be remember in the factor analysis how many methods of extractions are there. One it is the prime one, of course, we used to say that principal component method, which gives preference towards loadings. Okay, everything is give us loadings, but this is will focus primarily on the conditions which we have given. The unweighted least square method, generalized least squares method, maximum likelihood method, principal access factoring method, alpha factoring method, and image factoring method. The default, even if you are not going to select on the drop down, you will be getting principal component method. Now, normally I will tell you, we will go with the principal component method, nor maximum likelihood, otherwise alpha factoring. Alpha factoring, it is nothing but based on the reliability value of the data. Okay. Once again, I'm repeating, there are 3 things in general and widely is being used when it comes to the extraction methods. One, it is about the principal component method. Second one, maximum likelihood method. And the third one, alpha factoring method. Okay, this details, okay, kindly go through it in any research methodology book. Surely you will get to know, and that is going to be useful when you are going to understand this. So now, for the first time, when we are going to do it, let us start with the principal component method. Okay, as soon as I have done, I'm going for analyze. Okay, here there are 2 matrices there, but however, this matrix may or may not be useful. We won't deal much with this matrix. So let it be a correlation matrix, not a covariance matrix. And display what you want, unrotated factor solution and scree plot. The scree plot will tell you exactly how much variance has been explained by each and every statement on the factor. It is very important. An extraction method, okay, how you are want to go for it, it is known as eigenvalues. There's a concept called eigenvalue, which is normally which goes with greater than 1. Okay, it will select only greater than 1 options. In case I want to define a fixed number of factors for extracting, yes, I can do it, but it is not recommended. It is not recommended unless there is a need. Unless there is a need. Why? Because it will disturb the entire system. And when I can go with the fixed number of factors means when my literature says, okay, these many statements can bring only 2 state variables or factors by the time I can define. But however, I'm allowing my machine or the software to deal with its own calls and principles, that thumb rules. Okay, so I have kept it based on eigenvalue and maximum iterations for convergence. There is a concept called conversion. Normally, it is the machine itself will calculate. Sometimes it goes 75, sometimes it goes 120, something like that. Okay, let it be like that. So I'm not touching anything on this. Just I'm going as per the machine's recommendation. Once again, I'm repeating. Method, I have chosen the principal component method, that is extraction method. The second thing, it is analyze, correlation matrix. Display, I have enabled only scree plot. The unrotated factor solution, it is already been there. Based on the eigenvalue, I have chosen greater than 1, 2, that is you can define. but normally it is recommended that greater than 1. Okay, so I believe this step it is clear, because this is a very important one where you will decide which kind of method you want to go and further. So click OK. Let me repeat it. So far, I have a customized descriptive tab and customized extraction tab. And now I'm moving on to the step number 4 under the factor analysis. I'm going to customize rotation tab. What is this rotation? Rotation means it is a, when we keep the loadings in 4 quadrants, okay, one extreme to another extreme, that is going to be there. Okay, for that, let me explain you in Excel, so that Excel means I wanted to draw something, then you will be able to understand. Okay, just give me a minute. I'm loading that, because otherwise you may not be able to understand the complete perspective. Okay, just I'm going to take any one thing. Okay, I have kept it, and let me make it like this. Then this. Now I'm going to draw so that you will be able to understand. Okay. So let me draw it. For example, it is draw and so I want to select this. Sometimes this create. Okay, now it has been happened. Now it will be like this. Okay, any data which we have, it is going to be like this. I hope it is visible. It's going to be there. Some variables it is going to be loaded here. Okay, some variables it is going to be loaded here, and simultaneously it is going to be. Okay, the rotation, it means it will rotate towards this, and towards this. Okay. There is a 3 types of rotations is there. One, it is 90-degree rotation. Okay, when you read that rotation matrix, you will come to know that. The another one, it is 180, and another one, it is 360. And I'm going to rotate, okay, the entire loadings in a 90-degree angle, what happens? And on 180-degree angle, what happens? When it comes to the 360-degree, what happens? Okay. So when the loadings it is interchanged, okay, finally you can find it many variables, the observations will lie here only. The rest of the things, which is something like an outliers, will go out. Okay, and finally I can fix it. These many statements loaded here, these many statements loaded here, this many. This is called rotation. Okay, it's a very important one when it comes to the factor analysis. Okay, is there any doubt in this? Because this is a fundamental thing before we'll go with the rotation. Any doubts or any queries? Navya ma'am?
Sir, I don't find any questions in a chat box, sir. Probably there is no more questions.
Now let us move on to the this one. Now you can see that there are almost 5 methods are there. One, it is Quantimax method, Varimax method, Equimax method, direct oblimin, and the Promax method. Normally, the Varimax method deals with completely 180, not 180, 360-degree rotation, which is most widely used and most widely accepted method of rotation. A Quantimax, it is 90, Equimax is 180, and direct oblimin, it's all about delta and kappa. Then Promax is a kappa. That is, it is not required for us because it is completely deals with the statistical element. So Quantimax, it is 90-degree, Equimax, it is 180-degree, and Varimax, it speaks about 360-degree. which is normally recommended for that particular thing. Okay. So I hope it is understandable. Then we are going for the display, rotated solution, loading the plots. If you want to have a load the plots, yes, of course you can. Otherwise, you need not to do that. So what I'm doing it is, let me enable that loading the plots. This is step number 4, which completely deals with the rotation of the loadings. Okay. So what I have done it here, it is in the method, I have chosen 360-degree rotation, which is typically recommended by Variance rotation. And then you can go for it. In case, I'm telling you, in case if you are selecting none, it will not rotate the loadings and simply it will show you. But both the things will come when this comes to the factor analysis. I will tell you, okay, the output. Click continue. I've done so far 4 important methods when it comes to the factor analysis. One, it is about the steps which I need to execute it. Next one, in the descriptive tab, I have told you that you need to select initial solution, then the significant levels, then determinant, and KMO and Bartlett test of sparsity. And extraction is, of course, we spent good time with this particular thing, especially the principal component method. And even if you want to go for a maximum likelihood method, yes, you can. And alpha factoring also, it is possible. And one thing you need to remember, you need to enable this tree plot. And based on the eigenvalue only, it is going to be. And another method, if your literature supports, you can define number of factors. Rotation, that is what the final thing I have told you. I have chosen Varimax because I want to rotate the loadings into 360-degree. And I have enabled the loaded plots. Okay. By default, you will get rotated solution. Iterations already we have allowed 25 as per the machine's recommendation. This is one thing, the 5th tab or 5th step. How do you want to save that variable? Okay. And without saving also you can do, but it is always recommended. We need to go with regression saving, so that whatever we have convergence and whatever the rotations we have done, it is going to be available in your data editor. Okay, someone even in future, you can able to understand whether that EFA has been done or not by looking at your data editor window itself. We can able to understand. Bartlett test is an author, Anderson Rubin again another author. So all will think about that regression elements only. So click continue. Here we are not going to think about the coefficient matrix for factor score. So if you want to display, you can, but it is not required. And finally comes to this, as usual, explode the case list wise and pairwise and so on. Let it be like that. You need not to deal anything. So there are completely 5 important steps are available in the factor analysis. First one, I'm doing this, then I went to the descriptive button option and extraction, then the rotation and scores. Once everything is done, now I'm going to click on OK. Now everything is done, I'm going to click on OK. So just I wanted to understand from the participants, can you just tell me, have you got the steps which is involved in the factor analysis before we'll proceed quickly? Got the clarity before we'll proceed?
We are getting a response in the chat box, sir. Anil Kumar sir, Anand Kumar sir has responded, yes, sir.
Any queries so far before we proceed? Because this is the algorithm. Okay, step 1, step 2, step 3, step 4, step 5, and we have done completely on this. Now we are going for the next step, that is called clicking OK, and your factor analysis getting loaded. Just wait, it will load. Yes, we got it. Okay. Now, on your left side of your output, you can find there are a number of options are available, which has been executed. First one, correlation matrix, which will deal with the intercorrelation among the variables statements. Second one, KMO, okay, Kaiser-Meyer-Olkin measure of sampling adequacy, Bartlett test of sparsity. Okay, the third one, it is communality table, which speaks about the extraction method which I have followed. Then next one, total variance explained table, how much variance has been explained by each and every component. Okay, then the scree plot, as I told you, how it is going to be happen when it comes to the eigen. I will explain one by one. Just I'm started exploring the options which is available. This is component matrix before rotation. Please try to remember, this is before rotation. This is after rotation. This is going to be after rotation, and component transformation also it is going to be there, and plots also going to be there. This is what I was speaking. You got that component 1 and component 2, where it has been loaded, where it has not been loaded, and immediately you can able to understand how the things are flowing. Now I will tell you from where and how we need to start interpreting the factor analysis. Okay, please make a note of it. Please make a note of it. Okay. Now, first one, when I'm going to look into the factor analysis, I will start with KMO Bartlett's test of sparsity. Okay. Bartlett's test of sparsity. This is the first table which I need to look into it when I'm going for the factor analysis. From here only, I can able to understand whether the data adequacy, the sampling adequacy is there or not for my factor analysis or not. Okay, that's a one. Second thing it will speak about the degrees of freedom and further process in the factor analysis can be processed or not. That's the first table. Let me list out how the interpretation goes on, and after that we will go for it. Second table which you want to look into it is communality table. In the table we will look into it is communality table. The third table which we are going to look into it is total variance explained table. And I'm repeating, total variance explained table. Fourth one, I will directly go to the rotated component matrix if I have chosen any rotation method. Not you will get only component matrix. Not you will get only component matrix. At last, I will go with the component plot factors, how it has been loaded. And I'm repeating, KMO table, communality table, second one. Third one, total variance explained. Fourth one, rotated component matrix. And last one, it is about component plot in the rotated space, how it has been before and after. That is what we used to say. Okay, it is how it has been happened in this particular thing. Hope it is clear. And I believe that everyone has noted down how the sequence has to go when we are going to understand and interpret the factor analysis. Okay. So the first table, that is KMO and Bartlett test, it is going to be deciding whether the sampling adequacy is there or not for my data set. Okay. Now the condition is very simple. As usual, you know very well. Significant value only we will consider initially. Is if the p-value, significant p-value is less than or equal to 0.05. Okay, is less than or equal to 0.05 means yes, significantly adequate. Please make a note of it. Significantly adequate. The data sample adequacy is there. Significantly sampling adequacy is there for my factor analysis. Okay. Second value which we need to observe it here, it is the KMO measure of sampling adequacy. This is important. 0.836. Okay, 0.836. Again, Same thumb rule applies here also. 0.5 and above, it is good. And when it goes up towards closer to 1, it says that its good adequacy is there to perform. Normally recommended that 0.75 in 0.75 and above, it is always better. 750, it is better. In our case, it is 0.836. Yes, I'm confirming that this sampling, which I'm having an adequacy to proceed further in my factor analysis. Hope it is clear to all of you. If you have any queries, please let me know, because interpretation itself will take time. And after that, I will tell you how to remove the unmatched statements and so on. This is first step. Okay. Have you understood this up to this? Please type it in the chat box. Otherwise, unmute yourself if you have a query and ask me.
Yes, sir. Got a response.
Yes.
It's clear.
Okay, fine. Now, again, I'm repeating, we will look into the significant value, then we will look into this sampling adequacy. If both the conditions are good, then it's good to go ahead. Now, next table, communality table. Okay, you can see that the extraction was upon principal component analysis. Against each statement which is given, you find some values here. What is the value here? Extraction. First statement as 0.719, second statement 0.612, third one 0.713, and so on. It is going to be continued. And again, the benchmark, otherwise the thumb rule here, it is 0.5 and above, it is always better. Please make a note of it. 0.5 and above, it is always better. So now what I'm going to do, what it is, I'm going to remove these two from my questionnaire, which means the statements. Okay. Can't remember reading a book. Wish had more time to outside interests and hobbies. These two, I'm not telling that this will not contribute. Okay, we will confirm that how it is going to happen, but this is not extracted properly towards that variable, towards that factor. 0.5 and above, it is good. 0.5 and below, it is not good. Okay, less than 0.5 is not good. So all of you, please make a note of this. 4.471 and 0.404. So these two statements, I will remove it from the next time. Okay, no, but blindly we can't remove it. Please try to remember, blindly we can't remove it. The higher extraction says that higher contribution. Higher extraction value says that higher contribution. Okay. Now, total variance explained table. Hope it is clear. Any queries is there, ma'am? Someone, I think, typed it in the chat box.
No, sir. There are no queries in the chat box.
Now, the third one, total variance explained table. Let me tell you how we need to read this first. This component, it is nothing but the number of statements I have included for factor analysis. In case if I'm including 50 numbers will come. Okay. The number of components, it is nothing but number of statements which I have included in the factor analysis. First. Second thing it is, you can see that the total, this is not a biggest thing, but here you need to understand how much variance has been explained. The first statement itself, please try to remember, the first statement itself, it is explaining the variable almost 47%, means 47.7, which means 48%. The next statement is explaining how much? 15%. Put together, you can see that this variable can be measured with these two statements alone around 63%. Rest only it is going to be rest of the text. Okay. Once again, I'm repeating, this is a crucial one. Unless you understand this, then it is going to be very, very difficult. Okay. Now, you can see that the first statement itself explaining the factor that is a variable around 48%. When it comes to the second one, it is 15, but put together it is going to be 63. Okay. This is based on the eigenvalue, the scoring it is going to be there. Now, from here, I found that two components has come, which means it has two factors has been derived in this factor analysis. Two factors has been derived in the factor analysis. Hope it is clear. If you have any doubts, please let me know quickly. I believe everyone is noting it down. Any queries in the chat box, ma'am?
No, sir.
Now, yes.
Dr. Anil Anwa sir is asking, please repeat, sir.
Okay, fine. Please listen. As soon as we come to this total variance explained table, first thing I will look into the component column. Component column. The numbers 1 to 7, this indicates how many statements I have included for the factor analysis. I hope it is clear. As soon as I have observed this, I can able to find it out the percent of variance explained towards that particular variable. First one explains 48%, which means 47.7. The second statement explains 15%. Okay. The third one explains 10%. Fourth one 9, fifth one it is 6, and sixth one it is 5, and seventh one also it is 5. It is a minimal one. Put together only complete explanation can be done at 100. What I will do with it is, instead of increasing more number of statements, which is makes some difficulties to the respondents as well as for the researcher or enumerator, we will concentrate only these two. Even if I will be able to get only two statements, that two statements alone, my response is going to be the variance amount of variance explained at 63%. Minimum, it could be, I would suggest that above 50, okay. And when you go for more number of variables, it is going to be difficult. Let us understand this. Then I will take complete data set which we have, the statements. Then I will explain how it is going to happen. Okay. So, sir, is that clear? Is it clear so far? You can unmute yourself and tell me.
Yes, sir, it is clear. Got a response.
Now, next one, as I told you, the scree plot, it speaks about how loading it is there. It is from the total variance table only. Now, my question, now you go to the rotated component matrix, all of you. This matrix, it is after the rotation. This matrix after the rotation. Now, I want all of you to concentrate on the first statement. How much it is loaded after the rotation, which means time taken by job makes it difficult to fulfill my family duties. So here, heavily loaded, which means 0.841. Second component, it is loaded very minimal, 0.106. Okay. Now, this is rotated after the rotation. Before rotation, let us understand. You can see that very minimal. In the initial, it is 0.841, but here it is 0.831. So the loadings, it is going to be different. Let's take another one, the last one, forced to save my job, 0.266, 0.897, and here you can see that the loading, it is becomes negative, and here it is heavily loaded. Heavily loaded. Now, how do I decide? Okay, how do I decide that which are the statements are good to go with my further analysis? Here in communality table, I have told you we will consider about this 2 less than 0.5. Here I will say the same statement. It is better to remove less than 0.5 wherever it is not loaded. You can see that the first statement, first 2, 3, 4 statements heavily loaded on where component 1. But when it comes to the sixth statement, it is loaded equally, almost equally in both the components. Which means this variable or statement will trouble us. Okay, is it clear? Any doubts in this? Now, based on this one only, I'm going to finalize my factor analysis, that confirming my factors. Is it clear to all of you? Any doubts in this so far? Now I will.
Yes, sir, it's clear.
Okay, now I am going for it. Okay, this component plot matrix, it will tell you before rotation and after rotation how the data it has been, variables has been loaded. So not much difference about it. Okay, so now same thing, what I'm going to do with it is I will remove these variables. For example, mine here it is only this one, it is making problem for me. Can you able to see that? Which had more time for outside interest and hobbies. This one is here also the extraction it is least, and when it goes to the rotated component matrix also it is not properly loaded in any component. It is not loaded in any component. So I'm going to remove this first. Okay, it is not straight away. I can't remove all these statements. So let me choose this. So that I'm going to do. As of now, whatever we've done, it is an exploratory factor analysis. Please make a note of it. Whatever we have done, exploratory factor analysis. Now I'm going to do another one, that is continuation of the exploratory factor analysis. Go to the factor and click on this. Which variable it is? I found that which is not loaded properly, which had more time. So I'm removing it. Okay, I have removed it. Rest of the things, since I have done already, it is going to be there. You need not to worry. Let it be like that only. Just click OK. And immediately your things it is going to be displayed. Here there is no much change it because 0.825 it is good to go. But still you can see that can't remember reading book. It is loaded, extracted very less. And when this comes to the communality also, you can see that as soon as I removed two components put together explaining 68%. It's good. Previously, when I'm going to look into this communality, sorry, total variance, two variables put together explained only 68%. But here, what happens? 5% almost is increased. As I understand from the rotated component matrix, now you can see that there's a clarity in terms of loading. This is loaded clearly, this is loaded clearly, this is loaded, this is loaded, this is, and only one variable loaded on component 2. Only one variable loaded on component 2. This is how the factor analysis has to be done. And finally, I will present it in the form of table stating that the factor loadings, based on this only I'm going for it. Is there any doubt so far in this? This is method 1, which completely goes on eigenvalue method, which completely goes on eigenvalue method. Is there any doubt in this? I believe everyone is executing this.
No doubt, sir. Yes, sir. Got a response from the participants. They are executing.
Is that anyone has got 3 components? Just I wanted to understand. 3 components. No? Okay. Then even if it is 3 components, you can easily identify which component is loaded highly. Okay. When it comes to the rotated component matrix, rotated component matrix goes when it comes to the heavily loaded here only, not with this 2. Okay. Okay, fine. Any queries further? Shall we move to the next method in this factor analysis? Now, any queries, ma'am?
No, sir.
Okay. Now, actually looking at my data, this 8 statements or 7 statements is only one variable. Am I correct? There's only one variable. But my literature says it is perfect, but my data is not supporting. What should I do? In that case, you can define how many number of factors to be extracted. How many number of factors to be extracted. This will happen only when your literature not synchronized with the output which you got it. And I'm repeating. Here I have chosen 8 statements alone. Okay? But actually, as per my literature, it is a work family conflict statement which is measured. But when it goes to the factor loading based on my data, it is telling that the 2 statements or 3 statements has to be removed. At the same time, it is loaded in 2 factors, 2 variables. But actually speaking, it is only one variable which has been measured by 8 statements. What should I do for that? For that, again, there is a solution. Please make a note of it. I can customize number of factors which I want to get. Go to analyze. This is fixed factor method. Please make a note of it. Factor analysis using fixed factor method. Okay, fixed factor method. There are many methods is there, but this is the more frequently used things. Okay, these are the more frequently used things. Okay, fixed factor method. What I will do it is I will define. Go to the once again I'm repeating. Go to the extraction. Okay, you can choose fixed number of factors. That is, I need only one because my literature says only one factor. There is no role of second component or second factor. I'm defining it. Okay. I'm defining it. Is there any doubt in this so far? Because this is a second method which we are following it up. This is the second method which we are following it up. Don't believe that there is an query. Okay, let us continue. The rest of the things remain same. Okay, rest of the things remain same. Click OK. And here you can see that sampling adequacy is good. No doubt about it. It has been there. Terminology also, it is going to be there. The which variable which we have removed, you can able to see that these are the variables are troubling much. And when you go to the rotated component matrix, you will get only one component. Everything is loaded. But however, when I'm compelling the machine software, then sometimes it may trouble us in terms of the things. But again, it is advised that based on the data only we need to go ahead. By end of the day or by end of the analysis, we are going to say that which are the variable statements has been removed and based on which what. Okay, so it is advised that this method, it is not as an initial or primary option. Initial or primary option. This is a method number 2. Again, I'm repeating the method number 2 based on the extraction. Okay, based on the extraction. That is fixed number of fixed factors. Once again, I'm repeating. First one, I'm allowing the machine itself will go with the default system. Second one, I have eigenvalue method, first method. Second method is fixed number factor method. Again, in this, as I told you, maximum likelihood method also is there. Method number 3. Maximum likelihood method, which goes completely based on the respondent score. Please make a note of it. Maximum likelihood method will goes completely based on the respondent score. Okay. Click OK. And rest, either you can choose eigenvalue method or fixed number. As I told you, just keep, this is a primary one. don't go with the alternative. And click continue. When you click continue, you can able to get the Colmegro. You can see that it is going to be there. Communality, factor matrix is there. Goodness of fitness test is going to be there. Okay. Goodness of fitness test. Rotated component matrix also has done. And you can see that the maximum likelihood method, it is going to be there. Based on that only, all the factors, factor loading and everything comes. You can see that almost all it is loaded on this cubic, which means factor 1, and only one it is loaded close to factor 2. This is method number 3. This is method number 3, which is goes completely based on maximum likelihood method. Okay. Method number 4. Okay. Method number 4, which is commonly used, I'm using. Okay. Only extraction table we are going to change it. This is alpha factoring. You just click OK. And when click OK, then another thing also going to be come. When you observe it, these things will not change. Only thing it is that loading of the factors it is going to be different. Okay. It's all about how the things it's been happening and what are the major things it is going to be there and how it is loaded. That's it. Okay. This is all about factor analysis. It's all about the factor analysis. These are the 4 primary methods. One is eigenvalue method by using principal component analysis. Second one, principal component analysis method using fixed factor method. And the third one, eigenvalue method only, but we will go with the maximum likelihood method. The fourth one, alpha factoring method, again based on the eigenvalue. Eigenvalue, it is always default. It is always better to go with that. Okay. So that's it about the factor analysis, and based on this only we will decide. Now, let us go for one more thing. Before proceeding further, let me ask for someone so that whether they have understood or not. Any doubts is there? This is typically goes completely based on my literature support. Sometimes you may not have a clarity when it comes to the literature support. By the time how we need to go, that is the method I'm going to show you now. Okay. So, are any queries is there so far in the factor analysis?
No, sir. No doubt.
Now, before going into the next that method, okay, now just assume that I do not know which variable where it is going to be loaded. Almost up to this, we have 6 plus variables. Okay, 7 variables we have, and many statements are available as per our data. Sometimes no, we may not be having a supported literature with us. Okay, supporting literatures with us. Ma'am, someone has asked them to mute it. Who's this? Yeah, ma'am. Okay. Has that been muted?
Yes, sir. Muted, sir.
Okay, fine. Now, I have many statements here, but I'm not aware exactly, and I do not have a proper support of literature. By the time can we do the factor analysis? Yes, of course we can do, but one condition it is, after doing this, you can group it properly, and then again it has to be supported by the later point of time we can support it, okay, with the literature. So let me show you. This is how normally people used to do. Go to the dimension reduction and factor. Now I'm going to choose all the variables, which is one condition it is the statements should be measured in the same scale. Okay, that is very important. Otherwise, we are not supposed to go ahead. Okay, so I have chosen all these statements which has been used in my study. Okay, which has been used in my study. And one condition, as I told you, we need to have the measurement scale in a same, okay, liquid mean liquid, then so on. So descriptives, you know very well. I'm not going to change anything. Here, I'm going for a principal component method and basic eigenvalue method based on eigenvalue method. Number of iterations, we can go for 25. If you want to increase it also, you can increase it. Rest will remain same, rotation, varimax only. They're not going to do anything. Sports, that is going to be saved, and options, this remains same. Okay. Now I will tell you where the scores are saved. Okay. I will show you after this. This everyone must be aware because already it has been done almost 3 to 4 times. Clicking OK. Now we'll see what happens. Latest thing output, if you click on this, you will get to know. Okay, the latest output, if you click on this, this is the latest one. Because continuously it will come one by one. No? So sometimes it may lead to confusion. It's better you can go ahead with this. Okay, now when I take it together, you can see that the sampling adequacy is falls drastically. Sampling adequacy falls drastically. That is why we won't recommend this method. Okay, sometimes let us say that I have a data, sir, but I need some time for literature support. By the time we can go ahead with this. Okay, so now you can see that it is a drop in the sampling adequacy. It is an average level, okay, 0.6. And whereas when we look into the previous factor analysis method, it's 0.8 and above. Good, okay. And communality table, as I told you, it is goes. All the statements which I have chosen is going to be there. The thumb rule remains same. Thumb rule remains same, where it is loaded, where it is not loaded, and everything. Next one, you can see that 12 factors, sorry, 12 statements put together is explaining 78% of the variance. Total variance table, 78% of variance has been explained by 12 statements. Okay. And however, I wanted to understand whether, okay, whether the rotated component matrix, how many factors are there? 12 factors has been derived. Actually speaking, in my data set, as per my data set, you can see that only 7 factors or components are there. Now, when you have like this, you can see that lots of confusions are there. Authority highly loaded on 10th component. Own scheduling is loaded on 6th component. Freedom to decide, it is loaded on 6th component. What I will do it is, I will take the entire thing together and finally I will compile it. Now, I will copy this and I will show you how the final output of the factor analysis comes. Okay, just a minute. Minimize it. Okay. All of you can copy it so that you would be able to understand. Even you can export the data output. But now I just wanted to have it here. Okay, paste. 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 I've pasted it. So we got this. Okay, we got this. My work, primary work, when I'm going to present it in my paper, okay, even the previous things also the same way it is going to happen. Make sure that this one you need to do it. What I will do it is I will remove the lesser loadings, okay, minimal loadings, and here also I'm going to remove it. You need to do it very carefully because when you have more number of statements, here you can see that it is almost equally loaded in 2. there would be a problems actually. That is why we won't recommend this method. However, sometimes even when I'm not getting a data, this will help us in certain extent. Okay, you can see that this statement has loaded in 3 variables, that is factors. Okay, one by one I'm going to remove. And yes, this is good to go because it is heavily loaded on second component. I think this one also heavily loaded on second component. Okay, because this is an outcome we are going to present it. It is not like that, no, only by exporting from Excel, sorry, SPSS, your work is done. It's all about interpreting and presenting how the data it is going to be support your research. Okay. Finally, we will get the output. Just give me a few minutes. Let me test it. Delete everything, and then it is going to happen. Okay, this is one. Here you can find it. Oh my God, it is very, very minimal loading. Probably, yes, it is almost in the same as there. Negative loadings, please ignore it and delete it. There is no point of considering negative loadings here because the positive loadings alone it is required. Okay, this is how the things it is going to be there. How I'm doing this. Yes, of course, it is good to go here. Okay. Just I have finished a few. However, I will do it fast. This is all or negative. Yes, of course. I will go with positive highest. Here 3, delete. Here it is going to be double factor loading actually. When it comes to this, yes, almost okay. We can say that. This is a step 1 when I'm going to present my data, especially CFA, so EFA in my paper, okay, research paper. You can't simply take complete matrix and include it in your paper, and then it is going to be get rejected, okay, because people have no time or they may not require this complete data details. It's always better you format this and then go ahead. Okay. Now this is of course loaded in 2 if I'm correct, 3 up because almost it is close by values only. And after I'm taking the rotated component matrix, it is reflecting like this. One thing, please be clear, preparation of the data is essential and it requires real skill. Simply you can't directly get into any test and then perform and you will get some result, and based on that interpretation if you do it, and it will not serve the purpose of your research paper. It's always good to go with this analysis and probably that will help you out. Okay, I think it just goes too many variables. However, what I'm going to do with it is I will stop here, okay, because many statements are there. Okay, what we will do with it is we will take all these as an separate one. Normally, what we will do with it is we will ignore the blanks and then we can able to understand how many factors are loaded. So let me copy and paste it in a separate sheet because we have a lot of statements here which will consume more time for me to create completely. So hence what I'm doing it is I will be pasting it with this. It has happened here. Okay, let me show you what would be the outcome when you are going to do it. Okay, just a minute, it is loading. When you look into it, only you will be able to understand how the statements has to be presented in your article as well as in the thesis. Okay, just a minute. Alignment matters a lot when we are going with the understanding. Otherwise, we may lose the core essence of it. Okay, so it has been done. What I'm going to do with it is I will try to understand how many variables are loaded in the factor 1, 1, 2, 3, 4, 5, 4. How do I do what it is? We'll typically go with the filter option. Boom, go to filter, and you will get it. So here you will choose all blanks, remove that, and you get it. Now you can see that these 4 variables is loaded in the factor 1. Is it clear to all of you? Okay, what I'm going to do with it is I'm going to create another table. This factor, okay, factor number, here the statements, here factor loading. This is your outcome actually. Loading. The loadings. Loading, it is loadings. Now I will choose this. In a factor 1, it is loaded. Okay. I will compile together, merge it, and I will tell you this is 1, component 1. Okay. Component. Okay. Now let us look into the second component, how it is works. I will deselect everything. I will go to this as usual. Select all except the blanks. Immediately you will come to know where it is loaded, and you choose this and go down, and here you paste it. So immediately you can see that the factor loadings, it is going to be loaded. I didn't copied the second component, so let me copy and paste it in a respective cell. So the component 2, it is loaded here. Component 2, it is loaded here. Is it clear to all of you? Is this clear?
Yes,
This,
sir, it is clear.
okay, this is how the presentation would be done. This is how the presentation would be done. And finally, I will say that whether which variable or a statement it is loaded where, and you can able to conclude it. This variable comes to this component, and accordingly I will arrange my statements, and I will create my framework of the study. I will create my framework of the study. So there are 3 major things we need to remember when it comes to the factor analysis. First one, by default, your literature survey, as I told you. Second one, the execution of the factor analysis based on the methods which is available. The third one, how you are going to present it. Okay. Sometimes here some variables are not supporting. Statements are not supporting means we will remove that from our model, and then we will execute it, and we will confirm whether it is good to go or not, and based on that we are going further. Okay, so I think I have given a fair idea about the component matrix, and you can see that the loadings and all, it is how it has been loaded, and what are the major things it is going to be there, and the elements which can be utilized. So one suggestion, as I told you, it is always good to go with your literature survey. Don't select everything, and if you go all these statements together, it will consume more time as well as leads to the lots of confusions, and you may not be able to understand which variable you need to statement you need to remove it, and where it is loaded, where it is not loaded, and that will create a lot of mess when I'm going to conceive the framework of the study. And even I would say that multivariate analysis is going to be tough. and you may not be able to get supported by the hypothesis. Okay. So this is all about the factor analysis from SPSS. Okay. And that's it. Okay. If any queries is there, please ask me. For another 10 minutes, we have a time. I believe I have given a complete overview about it. Okay. Still, even if you are wanted to have some clarity on any other research things, also we can spend it. Why? Because I'm not starting the another descriptive statistics means, again, we need to have sufficient time to complete it. Touching and going may not be useful. So tomorrow we will proceed with the descriptive statistics. Okay. So any doubts or any queries in general, as well as with respect to the experiments which we have done it, that is hands-on training. Quickly, Navya ma'am, is there anything, or it is open to all? I will save this so that it is maybe people maybe use this.
Dear participants, kindly unmute yourself and ask your queries if you have any. Sir, I'm unable to find any questions in a chat box too.
Okay. You have any queries, ma'am?
No, sir. It was very much clear.
Okay. So just I wanted to understand how many of them have done, okay, have done this particular things. Okay, just tell me. And even now, if you have any queries related to your research, you can ask me now, because we have another 10 minutes more. Okay. Any questions or anything in terms of any analysis related or with another things? Okay. Even you can reach me out for your analytical solutions in this website. Okay. I will give you. Click on this, you can reach me whenever you have a doubt on that particular thing. Any doubts or any queries? I think I could have taken another 5 to 6 minutes, ma'am. Correct, because it is all done, okay, without leaving anything. I have completed with respect to the both things.
So that's okay. We don't have any questions from the participants. Dear participants, if you have any general queries about a research methodology or about SPSS in particular, you can ask. We will wait for another couple of minutes. And if we don't get any response, we will wind up the session for the day, sir.
Okay. One participant has called me, ma'am, but you have given a number, am I correct?
Yes, sir.
Oh, I was unable to attend that call. Possible, ask them to call me tomorrow. Okay.
Sure,
I
sir.
missed their number also. I didn't say it.
Okay, sir.
What about Rajesh, ma'am? Where is he?
Rajesh, sir, has not joined the session today, sir.
Oh, okay. Let's see.
So participants are thanking you, sir.
Okay, ma'am.
Yes, I think we will wind up the session for the day, sir.
Okay, ma'am.
I would like to thank you for your wonderful presentation. It was very much informative. especially about the factor analysis. I'm sure that the participants have got a clear picture about it. So I would like to thank you for your wonderful presentation, sir.
Okay, ma'am.
And we will join back tomorrow exactly at 5:30. I request all the participants to please join the session before time and try to be punctual. It is observed that some of you are joining late for the session. Please avoid it. Kindly join the session exactly on time or before time so that you can understand everything clearly. So today we will wind up the session and we will join back tomorrow at 5:30. Uh, One question. Thank you once again for enlightening us on new terminologies in SPSS. Yes, the participant is thanking you for enlightening on a new terminology, sir.
Okay.
So, thank you once again, sir.
Thank you, ma'am. Thank you. We'll close it for the day.
Yes. So, thank you, one and all dear participants. Thank you, sir.
Thank you,
Bye,
ma'am.
everyone. We'll
Bye.
meet tomorrow.
Good night.